Welcome everyone to Leveraging GIS in the PSAP. My name is Sandy Dyer. I'm a Client Success Manager for the DataMark team, and I'll be the moderator and co-presenter for today's session. I'd like to let everyone know that we are recording this session. All attendees have been muted for quality assurance purposes. Brian and I do encourage you to ask questions though, and you can do that through the use of the chat or the Q&A section of the platform. I think for most folks, they find the chat easier, but whatever suits you. We're going to try monitoring both as closely as we can. And we're going to answer any questions throughout the presentation, but then again, we have at the end of the presentation, we'll pause to see whether or not there's any remaining questions. So with that, why don't we go ahead and get started? So just a quick introduction of me. So as I mentioned, my name is Sandy Dyer, and I am a Client Success Manager with the DataMark team. DataMark is the public safety team of Michael Baker International. I am actually, just like Brian, a public safety. I come from a public safety background. I started as a dispatcher in 1990. Please don't judge the age of that. But I started as a dispatcher in 1990. I have had the value of being able to perform several roles throughout my career. From a 911 dispatcher, I was a master street address guide coordinator, I was a county 911 system administrator, where it was my job to manage 911 centers, the network, the budget, the equipment, the databases, that kind of thing. And then prior to joining DataMark, gosh, it's almost 2.5, 3 years ago now, I was a 911 project manager with the state of Arizona 911 program office, where my focus was on PSAP operations, wireless services, GIS, and next generation 911. And then to round this off, just want to share that I am a co-chair for various NENA working groups. NENA is the National Emergency Number Association and then the standards body for 911. And I have the blessing of co-chairing both GIS and PSAP operations-oriented working groups. I'd like to introduce to you my co-presenter, Brian McMurdo. Brian, can you share a little bit about yourself, please, sir?
Sure. Thank you, Sandy. Like Sandy, I've been in public safety for a while. You don't have to be ashamed, Sandy, of saying 1990. That's when I came into the public safety world too. So, I've been in public safety, the 911 center. I started off at a local center in Southwest Ohio, and was a dispatcher, a call taker there. Got involved in the training program, just really found that I loved it, and got into leadership, so into supervision, and had worked all the way up to operations manager, and had the opportunity to join the DataMark team. And so I've been heavily involved in Ohio, the Ohio chapters of APCO and NENA. I've also had the opportunity to chair the Ohio Gold Star Awards program, which is pretty neat. It recognizes the 911 professionals in the state of Ohio and the work that they do. So honored to be here with you all today, tuning in, and with Sandy as well. It's an honor to be able to present with you today. So let's just go ahead and jump right in. We'll take a quick look at our agenda. If you want to switch slides there, Sandy.
Sorry, there's a delay. I apologize.
No worries. So on our agenda today, we're going to answer that question: why the PSAP should care about GIS. And we're going to use some acronyms and some things. So PSAP may be an unfamiliar term to some of you guys tuning in today. And to clarify what that is, that's basically the public safety answering point, or the 911 center. You may hear it referred to as a ECC, Emergency Communication Center, or a ECD, Emergency Communication District. They're all kind of fancy ways to say a 911 center. So you'll probably hear the PSAP several times throughout our presentation today. We're going to move on then to leveraging the power of the PSAP and GIS relationship. We'll also talk about why error reporting saves lives. And then we'll finish up with observations in the PSAP for optimal GIS. So as we move in here, for public safety, everything we do comes down to location. The location of the crime, the fire, the medical emergency, or even just citizens just calling in need of some information. It all comes down really to location. And the dispatcher, we use various applications to support and convey location information. Sometimes we can become intimidated by the applications that we use to support our callers. Not realizing that a lot of these applications use kind of the same skills that we use at home. For example, I know everybody's heard of Google Maps, Bing Maps, Apple Maps, maybe even Waze. Maybe some of you guys use Waze. But it has address information and names of roads, and it can tell you how to get from one location to another. And it looks local, but it's really not. And while it may be able to find my house if I search my address, it really only knows that it's my house if I tell it. This right here is Brian's house. The GIS used in applications such as the CAD, computer-aided dispatch, 911 mapping, and next-gen 911 is a lot different. This is what we call local GIS data. And local GIS data knows that this is Brian McMurdo's house because of the data that is managed locally through utility addressing, addressing, parcel, permitting, or other types of data used in government. Generally, when you ask a dispatcher, what is GIS? The response is, it's the map. I've heard that many times, it's the map. Today, whether we realize it or not, we use GIS in the PSAP far more than just in a map. Whether it's used in the CAD to help verify a caller's address or to send emergency responders based on closest unit routing. In our 911 mapping to show us how the caller is moving every time we rebid for new wireless coordinates. Used to know the location of our units with our AVL technologies. And then in Next Gen 911, where GIS will become the heart of 911 network, the 911 network for caller location validation and for routing to the 911 center. Or as part of the emergency notification system or emergency alert system that uses GIS. Now, when I was a supervisor back in the 911 center, I had to utilize our notification system to notify some residents of some emergencies. One we had a critical missing 3-year-old, and he was outside. It was in the middle of the night. I was working third shift, and I utilized that system. Now I was able to pick that address, that the resident where the child was missing from, and do a radius from there. And I did probably select too wide of a radius and notified a whole lot of people. And in the middle of the night, but they did find the child, and he was still actually at home, believe it or not, but notified a whole lot of people that night. On a different occasion, we had the bomb squad that was out, and they had actually found a live explosive device, significant one, under a vehicle in a neighborhood, and used the notification system to notify residents on 2 streets in that area. This couldn't have been done without GIS, and GIS is everywhere in the PSAP, and optimally, everywhere in the PSAP that GIS is used, it's using the same GIS data set to avoid conflicts.
Okay, sorry about that, folks. I'm running into some technical problems on my end. Let me take the moment, thank you, Brian, for that, to say Brian and I enjoy more of a conversational type presentation. So if this seems a little unconventional, then that's why. So please anticipate that he and I may jump in at any point, either to share slides and to share thoughts, or to even ask questions of the other presenter. I meant to share that before we got started, and I failed to do so. But why don't we continue the discussion on why should I care about GIS? So what's kind of cool is we're seeing for the first time since 1994, when wireless phase 2 location information was mandated by the FCC, the most substantial change in the level of accuracy of location information for 911. So for those of you that may not be aware, and I'm going to read a little bit that's on the screen for you because this is a quote, but it's not all my dialogue is read directly from the screen, I promise. There's not a whole lot of slides that have the dialogue directly on there. But the FCC did adopt rules under Section 506 of the Ray Bombs Act to ensure that dispatchable location information is conveyed with 911 calls so the first responders can more quickly locate the caller. Dispatchable location information includes the street address of the caller and additional information such as room or floor number necessary to adequately locate the caller. These rules apply to the 911 capable services such as fixed telephony, which is your traditional telephone services, interconnected voice over IP, okay, so your voice over IP systems that are able to communicate with telephone networks, internet-based telecommunication relay services, and mobile text. Now, and that's text service, right? So mobile text service, SMS to 911, that type of thing. So as of 2021, compliance is needed by every fixed type of device, meaning the fixed telephony, the interconnected voice over IP, and the fixed video relay service, IP relay service, and IP caption telephone service to provide automated dispatchable location with each 911 call. Mobile text will follow shortly in 2022, where it's technically feasible. Otherwise, they'll need to provide either end user manual provision of the location information or enhanced location information, which may be coordinate based, consisting of the best available location. So what does this mean to the dispatcher and the GIS professional? What this means is that in order for 911 centers to be able to best locate the caller within multi-tenant environments or to the level of information that may be provided with the dispatchable location, we're going to need more defined GIS information. We're going to need sub-addressing, such as the building, floor unit, the seat that the call is placed from. Based on the FCC mandate, where it's requiring dispatchable location have better granularity of data that's sent as part of the 911 call, we're going to need our applications in the 911 center to have the GIS to be able to support that sub-addressing that is potentially to be provided. To do this, our GIS professionals may need to develop more defined information beyond the main address of the building. Now, I know that that's a heavy lift, folks, and I don't say that lightly. And I know that a lot of efforts, especially if you're focusing on next generation 911, has just been to get to next generation 911. And I don't want to deter you from that event. But when we're going to talk about why we should care about GIS, meaning the dispatcher and the GIS professional and how it's used in 911, and why those relationships are important between the PSAP and the GIS professional, I think it's good for all of us to understand, you know, the kind of calls that we're dealing with and the kind of information that we're going to need to support these. So when the data is developed, it will become available to the dispatcher for use during the emergency. So now, having said that, once the data is developed in next generation 911, it will be used even beyond just supporting the emergency when it's received by the 911 center. But even in today's environment, even if you're not next generation 911 and you are in an enhanced 911 environment, that more detailed information is going to be able to help you with these calls that are coming. But so some were required in 2021, mobile text 2022, right? So that those dates are actually probably quicker than a lot of folks are going to migrate to NG 911, unfortunately. So I do want to clarify. So I do want you to visit the FCC website for more details regarding dispatchable location. The little bit of information that I share is just a snippet. It's just a little bit of information. There's lots of information out there, as well as wireless Z-coordinate, which we're about to talk, or we're going to talk about next. The information that we're providing today is just to bring attention to these efforts and why GIS is important to the PSAP. So please don't consider anything we're going to offer today as a deep dive. But Brian, if you would, could you share in the chat the FCC links for our attendees, please? So if they want to take a closer look at all the references that I went to, and of course are within the PowerPoint itself, which I realize you can't click because it's a video, right? Or this is live. But you can actually go look at those and maybe do some additional research. Okay, so let's get back on track. So when considering that today, approximately 80% of our calls that we receive in the 911 center are placed from a wireless device, okay? And if additional location information like the Z-coordinate or altitude is being added to better locate the caller, we're going to need better GIS to support these calls. So right now, wireless coordinates contain a latitude and longitude, which provides you a two-dimensional view, meaning that when that call hits your map, it's flat. You know, it can tell you that I'm at this building or I'm on this street, but that's it. It doesn't tell you if you're above on a floor or below in a basement, or like here in Arizona, are you in the Grand Canyon and you broke a leg, and how far down to the Grand Canyon are you, right? All it knows is that it's two-dimensional because it's just the latitude and longitude that's currently sent. What's being anticipated, though, is the Z-coordinate. And let me share with you kind of what, let me share with you a timeline to help scope your intentions around it. So per the FCC, wireless providers that deploy Z-axis technology must do so consistent with a Z-axis accuracy metric of 3 meters above or below. So plus or minus 3 meters for 80% of wireless E911 calls. So we're not even talking next generation 911, we're talking about today's environment made from a Z-axis capable device. So the device itself has to be Z-axis capable. Wireless providers must also deliver Z-axis information for height above ellipsoid. And I threw that in there for our GIS attendees out there. Not necessarily for, I mean, it's good information for 911 authorities to know, but it's also good for GIS professionals. Where available to the wireless provider, floor level information must be provided in addition to the Z-axis location information, okay? So where is all this at? Well, per the FCC, technically, as of April 2021, 80% of all wireless 911 calls must deliver an X and Y location within 50 meters. Okay, so that's just the 2D, that's just the XY, or dispatchable location being civic address, floor level, room, office, apartment number for wireless 911 calls, April 2021. So for our public safety attendees, what I would like you, I guess, the advice I would give you and when it comes to Z-axis and the Z-coordinate altitude is talk to your 911 system service providers regarding any changes that you may need in your alley, your automatic location information, that information that comes across your 911 screen. Because there may be shifts in data, or you may need to find room for that Z-axis. And then also reach out to your wireless carriers to determine when this may impact you. So part of what's going on now is testing in 1 or 2 markets, or if it's available now, it's being sent. You may want to reach out to your wireless carriers to say, hey, is that me? And I'm just not getting it because my alley hasn't been updated. Or, you know, do you have an idea when it may impact me? I also don't want you to forget this may impact the information you pull into your CAD system, you know, with your CAD alley dump, and whether or not that's going to affect any changes in there. Just be mindful. So as of June 2021, the major carriers didn't exactly meet the April 2021 deadline, and they've entered into some consent decrees that contain some new requirements. Basically, throughout 2021, They'll be testing in various markets and providing statuses back to the FCC. By November 30th of 2021, after consultation with public safety, carriers must submit a proposal for PSAP education campaign on availability and delivery of Z-axis information. And then currently in the timeline, by April 3rd, 2022, carriers must comply with the vertical location requirements that would have been applicable to them on April 3rd, 2021.
We are getting a couple questions in, Sandy.
I see that.
Yeah. You would.
I don't. As far as, so the question is, how about what 3 words locations are they being used? I don't know. I'll just be honest with you. I don't know. I know that a lot of GIS professionals are adopting what 3 words, and that there may be specific deployments in GIS data. Now, whether or not what 3 words is being used from a wireless provider point of view is, I guess I would lean towards no, based on the way that wireless networks work, but I don't know that for sure. So I would reach out, especially for GIS professionals, reach out to your 911 authority counterparts and ask them. We have to remember, so everything about 911 is local. So while there's standards and requirements and everything out there to help support both enhanced and next generation 911, how it's actually deployed and what's deployed is a very local decision. So I would reach out to your 911 professional. Okay, so luckily to assist 911 authorities and GIS professionals, the National Emergency Number Association, NENA, has been working on requirements document for 3D GIS for E911 and NG911. And at the last NENA National Convention just a few weeks ago, they did share an update on their document and the progress of it. It's not yet available. It's still in the approval process. But you know, some really great information was provided at the national conference. If you know someone who attended the conference, they may be able to share with you the information that they got from the conference itself. The biggest thing I wanted to reassure you is that NENA has been aware that these mandates are out there, and they have been working on guidelines for GIS and 911 authorities to be able to meet those. They've worked very quickly on this document. It's very detailed, and because there's still some unknowns, there's still some future states, meaning additional things that may have to be addressed after the document's released, but they do want you to have that document in front of you in order to help meet some of these new location information, right? The new location information that the FCC has mandated on the wireless carriers. Now, I do want to stress, though, that this goes back to the need for well-defined and well-developed GIS data to support the dispatcher, whether it's in a 3D mapping or even initially as a sub-addressing effort, knowing how much sub-addressing is going to benefit how many multiple needs that we have, right? It's not just 911, although I think that's the most important one. Sub-addressing supports every level of government. So in this effort to support the 911 center, you could actually be supporting multiple business needs. So think about this. I mean, so you have a wireless call, and while the wireless call may not include sub-addressing elements in it, you wouldn't know if the call is plotting accurately if the dispatcher doesn't have sub-addressing to compare against what the caller's saying, or to be able to provide to emergency responders as to where to start looking in the building. Now, can they provide the lat, the long, and the altitude? They can, assuming that the emergency responders have the ability to use that information, and it is contingent on how accurate that information is when it's received. What's more valuable, what will always be more valuable, is going to be the conversation that we have with the caller and the GIS and the information we have in front of us to be able to test out what we're being told. Think about it. I mean, is the lobby really on the first floor, or is it just called the lobby? Is the penthouse on the 12th or the 13th floor, knowing that Some buildings don't identify a 13th floor. I mean, the last thing we really want our dispatchers doing in the middle of an emergency is to look at their map and start counting floors and hoping that's accurate enough to get emergency responders where they need to go. So the GIS data to support them is going to really help them with better situational awareness with the 911 caller until we're able to get to indoor mapping and other types of scenarios as a whole, right? So just because, again, I want to stress, just because you're not in an NG911 environment, if you are in a legacy 911 environment, these calls are still going to be coming to you when they're available in your area. And we need our GIS professionals to really support us in this. Now, the easiest way to accomplish dispatchable location and Z-axis is going to be starting with a really great data set to build upon. Well, one, okay, so before you go down this, kind of figure out what your needs are as a whole, right? From a GIS perspective, what are my needs as a whole? But if you are moving towards next generation 911, then you're already starting with a really great data set. NG911, for those that haven't heard this discussion, and if you've attended a DataMark webinar before, we talk about this quite frequently, so I apologize if this is going to be the boring side of things. NG911 is a GIS-based 911 system for location validation and call routing to the 911 center. And in next generation 911, GIS is replacing all those legacy MSAG and databases that we use today. More specifically, we're going to use the location validation function, this component right here within our NG911 network, prior to a 911 call being placed. And then we're going to use the GIS data sitting in an emergency call routing function during an active 911 call, utilizing a point and polygon spatial query based on the caller's location and the corresponding service boundary data, whether that's going to be your PSAP, law, fire, EMS. So starting your NG911 deployment, at least so we can get this far, is at least starting from a really great data set to build upon for your subaddressing. The reason that is because their NENA standard for NG911 GIS data model already provides the structure around the needs of NG911, and it includes the subaddressing that will be needed to support the calls that we just discussed today. So, and not just these types of calls, but obviously all the calls that we already receive. So there's a few conversations. The Z dimension will be a lot easier. How important will height attributed building footprints be in the PSAP GIS? You know, Sean, I'm not sure. If it's okay with you, I will take that question back and I will respond to you afterwards. And I apologize that I don't know. Normally, for these types of questions, I would have one of my GIS counterparts on the call today. And one wasn't available to join Brian and I, so I do apologize heavily about that. But if it's okay with you, if you don't mind outreach, I will find out that information and get it back to you. Okay, so I just want to drive home this one last thought about why I should care about GIS. And this is going to be true from a PSAP and from a GIS perspective. So 911 and the management of data behind it is actually an exercise in trust. And I had this conversation with someone recently in the last couple of weeks. I have for over a decade now been trying to figure out how to blend the relationship between our PSAP and our GIS professionals, and wondering why sometimes that there's a disconnect. And as to either the 911 professional not understanding why they need the GIS professional, or the GIS professional not understanding why they need the 911 professional. And at the end of the day, everything that we do in 911 comes back to our citizen, okay? And when our citizen calls 911, they're trusting our 911 authority is doing their due diligence, and the management of their data and to have the knowledge to find them and to send help. Okay, so 911, the citizen is trusting the 911 authority. The 911 authority is trusting their GIS data providers to provide them high quality, validated GIS data to support the 911 caller, whether that's a physical address or latitude, longitude, and altitude in the future. Now, the GIS data providers are actually relying on all those folks, like the planning departments, public works, permitting, addressing authorities that they consume data from, that they're doing what they need to do to ensure high quality information is being provided to them so they can support the 911 authority, who in turn is trying to support the 911 caller who's placed their call. We can ensure that this exercise in trust isn't broken when we leverage this GIS and this PSAP relationship. The other thing I realized is that a lot of 911 professionals, to be honest with you, aren't necessarily aware of how 911 works today, like the MSAG and the ALI databases. I know for 12 years as a dispatcher, I answered that phone and it was just magic every single time. I don't know how the stuff showed up. It just showed up and it was wonderful, even if sometimes I thought it was broken, right? But it showed up. I didn't realize there was somebody in my building that was helping me do that. And so I was thinking about that as well, and thinking about how here in Arizona, we have, roughly 80 plus 911 centers. We only have like 15 MSAC coordinators, that legacy database coordination, and that helped to produce that magic when I answered the phone. But I have thousands of dispatchers and people in the 911 authority realm who don't know how the call happens. And in recognizing that, I also recognize that that may be one of the reasons why our 911 professionals aren't reaching across the aisle to our GIS professionals, realizing how important their data is in order to do not only what they do today from their CAD, their 911 mapping, their AVL, their ENS, whatever the case may be, but next generation 911 also. So this is my, I guess, plea to you about why you should care about GIS, is because you actually need each other more than you realize. And you need them not only today to support the location information that's coming in, but you're really going to need them for next generation 911. All right, Brian, I'll turn it back over to you so folks can stop hearing my soapbox.
No, that's excellent, Sandy. And I think that, that's something that throughout a lot of these webinars, we hear a lot of that relationship, the stakeholders at the table. So often I think in a typical center, you have a lot of interaction with the police and the fire, the EMS. They're usually at that table, and that's something I think is important too, and it's important to be on that soapbox to say, this is an important relationship, and we've really got to embrace it. GIS has to be at the table, and so, but as we move into this next slide, I mean, why is the relationship so important? And I think we can look at the GIS relationship as much like, for those of you in the PSAP, is like your CAD administrator relationship. GIS manages your data to support many of the systems, your systems in the center. Accurate location information, whether you're using GIS to validate your 911 caller's location and route the call to the proper PSAP in Next Gen 911, or use the GIS to validate, verify the location or validity in the CAD. You're using the mapping to place where the caller's calling you from on the map. There, you're placing you on the map, and the caller's sitting there telling you, "I'm right here. I'm right here," and you're moving the map, moving it around, trying to find exactly where they're talking about, locate them there. Or use GIS to route your emergency responders. All of this, it's really all about connecting the dots. And GIS professionals, they rely. I've learned that they rely on dispatchers and first responders to let them know when there is a problem. And then this is a good thing, because when we find this issue or problem, we can let them know about it really kind of in real time and real life. And I think we can look at it as connecting the dots, kind of like the connecting the dots game. And I always enjoyed when I was younger getting the Sunday paper. I know that may sound crazy, but we'd have it delivered to the house, and I liked it just for the comics, really. And on the back of the comics was always a connect the dots picture, and that was probably my favorite part of it all. But I think we can, if we can kind of think about connecting the dots as we move through here. GIS puts together roads, which are lines, address points, and community information to create a picture for you that with needed information, describing the geographic location. If an address is wrong in the system, or a road looks like it goes through and connects to the other road, but it truly doesn't, or maybe that road's not even there at all, then the proper information or the picture isn't being provided to support the emergency. So your GIS person, they may think they're providing you a picture of a duck, when in all reality, that is actually a chicken, and then they didn't realize that there was a problem. So, you probably tuned in today not even thinking you would see a chicken and a duck on a PowerPoint, but they may think they're giving you a duck, but it's really a chicken. Now let's look at what this would look like from a kind of a GIS perspective. Got a couple examples here. So look at this connect dots. What you're seeing here is called a fishbone. And a fishbone is a tool that is used by GIS professionals to see how well the address point location corresponds to the roads. Now, why is this important? If you use GIS to support closest unit response and unit routing, then the road information is what's used by your CAD and AVL systems. You want the emergency location to be recognized on the road in the same area as the actual address. And in this example here, we see that 738 Ellington Run Court is located right here. Got a little circle that pops up there. So it's located right here. Now, although it connects to the road all the way there at the very end of the road, we can see that 738 is incorrectly addressed. Either it's incorrectly addressed, or it should be Ellington Run Road, or possibly the house number of 708. Or is this how it is in real life? And it can't be changed. Should the road range be adjusted? Either way, this can cause emergency responders to not find the emergency. And that's not a good thing. Your GIS person may not know that this is a problem unless it's reported to them. Now, there are tools that can be used to prevent or to help find these concerns, like the fishbone, but not every problem will be found this way. So it's really important. It's really important that it's reported. So there in the PSAP, if you're a 911 professional there, maybe a dispatcher tuning in today, or a supervisor, or whoever, very important that you report these problems. So I want to take a look at another example here. This one right here, we're seeing. Actually, let me catch up here. There we go. So this one, we have duplicate roads, which would really delay an emergency response. And while they know when they get there on scene that there's a problem, we run the risk of a delayed response when the GIS is incorrect. And especially if you notice here, if any of you tuning in are noticing something, this little dot right over into the kind of like the center left, I got a little circle that's going to pop up here. There we go. It's a big problem, especially when you have an address out there that doesn't connect to a road. So
I'm sorry, Brian, I'm responding to a question. I'll pay more attention.
no, you're okay.
Sorry, sir.
It's okay. Thank you for switching that one though. So so now we're talking about why error reporting saves lives. Error reporting is just a big opportunity to improve every road, every address, and community information, and the services that utilize this information, such as 911 and emergency response, just hugely going to benefit from that. So knowing that all the applications that use GIS in the PSAP, and hopefully it's the same GIS, the dispatcher can correct data in all the applications when they report errors found while using one of the applications. So dispatchers do have a voice. And they're really kind of front lines. And they can enact significant and necessary change to GIS data. However, they have to have a way to report problems that's really quick and efficient. Knowing that so many of the applications used in the PSAP rely on GIS, they should have one mechanism for reporting all GIS problems. And I think another important thing really to identify here is they need feedback as to what happened with the error that they reported. Otherwise, they may stop reporting it if they don't think that anything's happened, or that problem's been fixed, or there's kind of no response to that. And if that problem isn't fixed, and pops up again, then they could be like, why do I even worry about, notifying anyone about this problem? So important to get feedback as well.
It is. And Brian, sometimes I know that when I used to troubleshoot problems that were reported to me, it turned out there wasn't a problem at all. It turned out that what it was actually what it was supposed to be. There was, I have a specific scenario where they asked me to change the address associated to a telephone number because, and when I looked it up, they had the woman's first name, according to the address that they said it should be, was the same. But then according to the address that it was already in 911 was the same too. So it was like the reporting party's name was Lori, and the owner of the property that the address was assigned to was Lori. What they didn't know is Lori from the neighbor's house ran to this Lori's house to make the phone call. That wasn't clear in their dialogue. So they were telling me, change the address to this phone number. Well, had I changed the address, I would have actually taken what was a correct record and made it a wrong record, because technically that person didn't have a phone. I would have shifted all this to a wrong address.
Yeah.
But part of that feedback is going, hey, look, this wasn't broken. Let me tell you why it wasn't broken, or let me tell you what happened as a result of that, right? So it's not just about reporting back when you fix an error. It is about reporting back just in general to let them know that they've been heard.
Yeah, no, I totally agree with that. And I think doing your due diligence to research that, because that could cause a whole nother set of problems if you're just changing it. But I agree, like giving that feedback, like, hey, this was the situation, here's what it was, and this is why we didn't change it. I think that definitely gives them a good understanding.
Right.
I think
and that's true of anybody, not just public safety professionals, right?
Yeah, I think that line of communication will stay open. So very good. Yeah, thanks for that input. So as we move here, one way to make reporting GIS errors quick, efficient, and as a single mechanism to report the stuff through is observation points. And when an error is found in any one of the PSAP applications, the dispatcher can just drop an observation point and share what they know went wrong. When that observation point then notifies multiple people all at once, so your GIS, your CAD administrator, supervisors, 911 authority, for instance, and then once that resolution is made, the dispatcher is notified of what happened. And we do have a quick little video here that I'd like to show you of how this really all works.
The observation tool promotes collaboration between the people managing GIS data and other important stakeholders, such as first responders or dispatchers. A non-GIS stakeholder can place a spatial point in the GIS data, notifying the GIS data managers of a change or modification needed in the GIS data. Then a notification is sent to the GIS data managers and to additional stakeholders outside of VEP. After the observation has been submitted, a GIS data manager can review that observation to see if the change is needed. The submitter of the observation will receive an email notification once the GIS data managers either resolve, cancel, or delete that observation.
So by reporting the errors and having the tools to ensure that they are resolved, you'll improve every road, address, and community. And then by leveraging the PSAP and GIS relationship, we can ensure that the trust associated with 911, the 911 call, remains intact. We all know, all of us know that in an emergency, seconds are important. Seconds save lives. Well, accurate, complete, and updated GIS data, that'll save seconds. So I just want to, Sandy and I want to thank you for your time. Thank you for your questions and online there. But if you have any more questions, we got a little bit of time left that we can try to answer those for you.
And we did get several questions that I responded to directly as where I could, and then one accidentally responded to someone who didn't ask it. So apologies if that happened. I know that generally data mark presentations are centered around GIS and how to handle GIS next generation 911. We also feel that bridging those relationships between your GIS and your 911 professionals is just as important as technically knowing how to do this. As well, we wanted to offer some real life examples or some real life scenarios that could be happening today that reinforces why that relationship is important, right? Whether it's the dispatchable location or Z-axis or any of those things, right? Sometimes it's hard when the conversation is always about next generation 911, sometimes it's hard to get people to understand the value. So we wanted to be able to offer something that was happening today to maybe help you further along the conversation. I do want to let everyone know that the video will be shared with you. And if you did send me a question that I want to reach out to one of our GIS professionals on, not that I don't know how to answer the question, but I would prefer that that come directly from a GIS professional. I say I'm a GIS person because my entire career has been about location, whether in the 911 center or otherwise. But I don't profess to be a GIS analyst or professional in a more technical realm. So I will get those informations out to someone and we'll respond to you directly. If there aren't any questions, we'll go ahead and let you adjourn for today. Thank you so much for joining us. And as you know, we have a free webinar every month. So tune back in, register. The majority of them are specifically GIS related. All right. Have a good one, folks.
Thank you all. Have a great
Thanks,
day.
Brian. Thank you so much for doing this with me today.
Thank you, Sandy. It was an honor to do it with you. Appreciate it.
Bye, Hen.
Bye-bye.